Hey everyone, welcome. Today we're going to dive into a set of PLC instructions that are, honestly, absolutely critical for writing clean, predictable code, the one-shots. These are the secret sauce to gaining precise, single-scan control over your logic. And trust me, they'll save you from some major programming headaches.
I mean, think about it for a second. The entire world of PLCs is built on loops, right? They scan code over and over and over. So how in the world do you make something happen just once? How do you press a button and have a counter go up by 1 instead of, 1,000 in that split second your finger is actually on it? That's the exact puzzle we're tackling today.
And this right here is the heart of the problem. You got to remember, a PLC is just unbelievably fast. It's scanning your entire ladder logic program thousands of times every single second. So if a switch is on, the PLC is going to execute whatever instruction is connected to it every single time it scans. You can imagine the chaos that would cause if you only wanted that thing to happen once.
All right, so here's our game plan for today. First, we're going to really nail down this repetition problem. Then, we'll introduce our foundational tool, the ONS. From there, we'll explore its opposite by looking at rising versus falling edges. And then we're going to unlock some real power by comparing the ONS to the much more flexible OSR. And finally, we'll put it all together so you'll always know which tool to grab for the job. So let's really dig into this. Imagine a super simple instruction. Add 1 to a counter when a switch is pressed. Simple, right? But if that switch stays pressed for even half a second, the PLC might scan that logic 1,000 times, and suddenly your counter is at 1,000. That's not what you wanted. We need a way to tell the PLC, hey, listen up, only do this the very instant that switch first turns on, and not a single scan later.
Okay, so how do we solve this mess? Well, we start with the most foundational tool in our kit, the ONS, or the one-shot instruction. This is your #1 go-to solution for taming that repetition problem.
So, what does that actually mean? Well, you can think of the ONS like a super strict gatekeeper. It just sits there watching its input. And for that one single fleeting moment, literally one scan, that the input goes from off to on, it throws open the gate and lets the logic pass through. After that single scan, bam, the gate slams shut, and it stays shut, even if the input is still on. And that false to true moment, that has a special name. We call it the rising edge.
Okay, let's unpack that a little. First, it triggers on that rising edge we just talked about. Second, and this is a key detail, trust me, it's going to be super important later, it's an inline instruction. That means it sits on the left side of the rung and basically acts as a condition for everything that comes after it on that one specific line of code. And to work its magic, it uses a single bit of memory. Just remember what the input state was on the very last scan.
All right, so triggering something when an input turns on. Super useful, right? But what about the other way around? What if you need something to happen the exact moment an input turns off? I mean, that scenario is just as common, and for that, we need a totally different tool.
And for that, we have the OSF, or one-shot falling. It's the mirror image of the ONS. It does the exact opposite. It patiently waits for an input to go from on back to off, and in that single moment of transition, for one scan only, it fires. We call this the falling edge.
And looking at them side by side really just makes it click. I like to think of it like a camera flash. The ONS is like the flash going off the instant you press the shutter button down. But the OSF, that's like the flash going off the second you let go of the button. So if you want to start a timer the moment a button is pressed, you use ONS. But if you want to count a box only after it has fully passed the sensor, the OSF is absolutely the perfect tool for that job.
Okay, this brings us to our final one-shot, the OSR. And this one introduces a concept that is just so powerful. And that concept is flexibility. Because let's be honest, in the real world, one single event often needs to kick off a whole bunch of different actions all at the same time. Now, here's the thing. At first glance, the OSR, it looks almost identical to the ONS. It triggers on the exact same condition, that false to true rising edge. But how it delivers that one-shot pulse is fundamentally different, and that difference is an absolute game changer. So, remember how we kept mentioning that the ONS is an inline instruction? This is where that really matters. Think of it like a gatekeeper standing on a single road. It can only control the traffic, the logic, on that one specific rung. Its influence is totally trapped. It doesn't extend anywhere else in your program.
And this is what makes the OSR so different. It's not a gatekeeper on one road. It's more like a broadcast tower.
When it sees that rising edge, it doesn't just affect its own rung. No. Instead, it flips a special dedicated output bit to on for one single scan. And here's the magic. You can use that one little bit as a trigger anywhere you want, on as many rungs as you need, all across your entire program.
So really, it all boils down to this table right here. The ONS is an inline instruction. It's great for simple, self-contained actions on a single rung, but the OSR is an output instruction. It gives you a reusable bit that lets you trigger multiple, widespread actions from just one event. That is the core difference you need to remember. Okay, that's enough theory. Let's get practical. We're going to walk through a few real-world scenarios so you can see exactly when to reach for each of these powerful tools in your toolbox.
All right, scenario number 1. An operator presses a single button, but from that one press, you need to do 3 totally separate things. Increment a counter, grab a timestamp, and reset a timer. How do you make sure all 3 things happen at the exact same time, down to the millisecond? Yep, you guessed it. The answer here is the OSR. You'd have the button press trigger the OSR, which turns on its output bit for just one scan. Then, you can use that single output bit as the trigger on 3 separate rungs. One for the counter, one for the timestamp, and one for the timer. It's clean, it's efficient, and everything is perfectly synchronized.
Okay, here's another one you'll see all the time, especially in manufacturing or logistics. A sensor turns on when a box arrives, and it turns off when the box leaves. You want to add to your count the exact moment the box is gone.
This is textbook OSF. It's exactly what it was made for. The instruction completely ignores the sensor turning on. It just waits and watches for that true-to-false transition, the falling edge. And only then does it trigger your counter, right when the box has completely cleared the sensor.
All right, last one. Let's keep it simple. You have a single, straightforward task. When an input turns on, you just need to start a timer. And the timer logic is right there on the same rung. Nothing else in the whole program cares about this event.
In this case, the ONS is your best friend. It's the clean, simple, and most efficient choice. You just pop it in line right before your timer instruction, and you're done. No need to overcomplicate things with an OSR when you don't need that program-wide signal.
Okay, so let's bring it all home. Think of this table as your ultimate cheat sheet. For simple, inline actions on a rising edge, you grab the ONS. Need to act after an event is over, on that falling edge? That's a job for the OSF. And when you need to trigger a bunch of different actions all over your program from a single rising edge, you need the power and flexibility of the OSR.
And there you have it. You now have the power to control the flow of your logic with single-scan precision, whether that's at the beginning of an event, at the very end of it, or broadcast across your entire system. This isn't just some programming trick. It's a fundamental skill for writing clean, robust, and predictable automation. So the only question left is, what complex process are you going to go out and tame with this newfound control?